The average lifespan of humans in most countries has only slowly been increasing over the past few decades, but now, with the help of emerging biotechnologies, scientists are predicting the average lifespan of people who are under 50 today to be in the high 130s, and with people who really want to, being able to reach the late 100s. And most importantly, the scientists are talking about healthy lifespan, not the type of health a currently 90-year-old is subjected to. You might wonder how they are so certain, but very recently, longevity researchers have found some of the functions and areas in our bodies which cause most of the accumulative damage which we tend to call aging and how to actually target or treat them. Welcome to today's episode of AI News. In this episode, I will talk about how all of the recent advances in longevity are the most certain way we'll be able to visibly delay the aging process, how the scientists plan on actually achieving that, and finally, what this could mean for the future of society and the medical industry. For decades, the number of people living to be 100 has been increasing, reaching over 500,000 people globally. There are significantly fewer supercentenarians, or those who live to be 110 years old or more. Jeanne Calment of France was the world's oldest living person when she died in 1997 at the age of 122. The current world's oldest person is 118-year-old Kane Tanaka of Japan. People are captivated by humanity's extremes, whether it's flying to the moon, running in the Olympics, or even living as long as possible. We can now estimate how likely it is that someone may reach different extreme ages this century thanks to recent technological breakthroughs. According to one of Wall Street's top investment banks, firms aiming to delay human mortality will be one of the most lucrative investment possibilities over the next decade, with a market valued at least $600 billion by 2025. Analysts at Bank of America Merrill Lynch Felix Tran and Chaim Israel think that genome sequencers like Illumina, high-tech players like Alphabet, and biotech firms like Novartis are on the verge of providing extraordinary improvements in human lifetime quality and duration. Genome science, big data, and immortality research, which includes wearable technologies and wellness goods, might soon extend healthy human life well beyond 125 years. According to leading experts, medical knowledge will quadruple every 73 days by 2020, compared to every 3.5 years in 2010, and genome sequencing prices have dropped 99.99% since 2003. This has ushered in a new age in precision medicine, extending life expectancy even further and ushering in a tech-manatee revolution. Extending human existence to new frontiers, which has long been the stuff of science fiction books, might become a more appealing method to generate money on the stock market. With a market cap of $110 billion, the Bank of America team identified 5 major sub-themes: genomics, AI health, future food, immortality, and moonshot medicine, as well as a number of equities that give exposure to the trend. According to the Bank of America, genomics, or the study of the human genome, is anticipated to be a $41 billion business by 2025, and will deliver the next generation of gene editing technologies, possibly bringing significant breakthroughs in illness prevention and treatment. Companies like Illumina, which has a market capitalization of $46 billion, Agilent, which has a market capitalization of $27 billion, and Danaher, which has a market capitalization of $89 billion, all have a stake in the area. Novartis' new Kymriah medication was the first FDA-approved type of somatic gene therapy. It was created to aid patients with B-cell acute lymphoblastic leukemia, which is commonly known as ALL, and is designated for the 15 to 20% of patients whose disease has not responded to previous alternative treatments. After a median of 29 days, 83% of the 63 patients in Novartis' first clinical study were in remission. However, Kymriah has significant to deadly adverse effects. In other clinical studies, individuals have died from cerebral edema, which is defined as a disease in which excessive fluid causes the brain to enlarge. Another example of gene therapy is the firm Spark, which set out to develop a solution for an illness that had no other options. There were no treatments for any of the hereditary retinal disorders until Luxturna. Doctors could only give visual assistance to individuals with retinal dystrophies, but as youngsters become older, their eyesight deteriorates. The Kellogg Eye Center at the University of Michigan has successfully treated children with hereditary visual loss. The FDA authorized Luxturna, the first treatment to treat this condition, in late 2017. Because it targets a genetic disease, this germline gene therapy was also the first of its kind to be authorized. Luxturna and similar medicines will likely be the subject of long-term research in the future, to discover if the offspring of these patients carry along their removed hereditary diseases, or if the treatment just heals the given generation. As with many new technology, there is worry that genome editing will only be available to the rich, therefore exacerbating existing inequities in healthcare and other treatments. Some fear that if germline editing is pushed to its logical conclusion, it would create classes of people characterized by the quality of their altered genome. Some fear that obtaining informed permission for germline treatment will be impossible because the patients impacted by the changes are the embryo and future generations. The counterargument is that parents already make a lot of decisions that impact their future offspring, including PGD with IVF and other such difficult considerations. As long as the dangers of germline treatment are unclear, researchers and bioethicists are concerned about gaining fully informed permission from prospective parents. Because of the risk of incorrect changes and when some cells carry the edit but others do not, safety is a top priority. Researchers and ethicists who have written and spoken about genome editing, such as those at the International Summit on Human Gene Editing, generally agree that it should not be used for clinical reproductive purposes until germline genome editing is deemed safe through research. The risk cannot be justified by the potential benefit. Some scientists believe that genome editing in embryos will never provide a benefit larger than that provided by existing technologies like preimplantation genetic diagnosis and in vitro fertilization. However, scientists and bioethicists agree that germline editing can sometimes meet requirements that aren't fulfilled by PGD. This includes cases where both prospective parents are homozygous for a disease-causing variant. They both have 2 copies of the variant, so all of their children are expected to have the disease. Polygenic disorders influenced by multiple genes, and families who object to certain aspects of the PGD process. Some researchers and bioethicists are concerned that utilizing genome editing for medicinal purposes would lead to its usage for non-therapeutic and enhancing goals, which many consider to be problematic. Others say that genome editing should be permitted to treat hereditary illness once it has been shown safe and efficient, and that it is a moral necessity. Concerns regarding enhancement, they argue, should be addressed via legislation and regulation. Finally, critics on the topic are concerned that the use of genome editing for reproductive reasons will be governed differently within and outside the United States, resulting in usage that the American public would find disagreeable. These reasons point to the highly self-regulated settings of reproductive clinics that provide PGD and IVF, as well as existing regulatory disparities between nations. Biotechnology is a large field with many intricate details, but it is also neither black nor white, which is why the FDA is constantly working to benefit the public through innovation and vigilance. Common medicines such as vaccinations, antibiotics, insulin, and hormones have been standardized to benefit people of all socioeconomic classes because most are covered by even the most basic of insurances. These, too, are steps toward an ethical medical future in which even the poorest of families have access to the same medicines as those in higher socioeconomic classes. While there may be difficult terminal diseases that we may research further today, there are still nations that require previously existing medications or potentially new goods, as the firm Syngenta has demonstrated. This is in addition to all of the job and financial ramifications that would result if Americans lived to be 100 years old on average, as well as the swole of the robotic industry taking over. One dilemma that arises is if we should prolong human lifespan beyond what it is now. Opening the door to germline gene editing might lead to population overpopulation, which would push the world's population over its carrying capacity far faster than we would be able to support proper life, ending up with a shorter lifetime than scientists had anticipated.
In this case, he did the work in mice. You take the placentas of that mice, you convert it to dosages of stem cells that you then give to that mouse at the end of its life. Like in this case, typically a 26-month-old mouse, you will extend that mouse life another 30 to 40%.
Whoa.
Right? You'll add another year almost onto it. And that's been repeated in a number of different ways. There's a whole thing called the Youngblood experiments being done at Stanford. And right now the experiments are going on in humans as well. That if, it's sort of like sort of Dracula and the vampire, but if you take the blood of a young individual and transfuse it, or the plasma, not the cellular portion,
Right.
into an older person, you will get a lot of return to youthful state. And in reality, it turns out that there are a number of stem cell clinics outside the United States. And I happen to know a number of 80-something-year-old billionaires who go and don't get young blood infusion, but get stem cell infusions.
So, what is your opinion on the average human lifespan increasing this drastically? Are you happy that there's such a good chance for you to take advantage of it, or are you one of the few who wouldn't, even if it did increase the amount of healthy time you'd spend on this earth? What about the societal issues this could cause in terms of the job market and elsewhere? Please tell us your opinion in the comment section below. I would love to hear what you have to say about it. Thank you for watching AI News. We consistently report on the newest technologies that are shaping the future of our world. We'd appreciate you subscribing and watching our other videos. See you around and take care.